Example 6, lesson 5.2. How can you rewrite this without a radical in the denominator? Lots of math geeks out there hate having square roots in the denominator. Similar to, have you ever seen, remember when we had like 3 plus I over 2 minus I? We hated having I in the bottom. Do you remember that? The students say yes. Good. And so we multiplied top and bottom by, what was it? 2 plus I. What was that called? The conjugate, okay? And the reason it worked is it got rid of the I in the bottom. Here's how it worked. I'm only doing this so you can see how today's lesson is similar to this, all right? When you did first times first, what did you get? 4. When you did the outside, you got a minus 2I. And when you did when you did the inside, you got a minus 2I. And what happened there? They canceled. And then we did last times last, which was negative I squared. But we all remember, right, that I squared is negative 1. So the denominator ended up being 4 plus 1, or 5. So all this stuff was over 5 instead of being over an I. So that's called rationalizing the denominator. There, we were making the denominator a real number instead of imaginary or complex. Here, we're going to try to make the denominator a rational number, and we're going to use the same technique. So let's all multiply top and bottom by the conjugate of this. Instead of plus root 5, we're going to multiply by 2 minus root 5. The same technique will apply and will work here, and you'll see why in a moment. Ready? In the numerator, distribute. 1 times this stuff is just this stuff. In the denominator, that moment is soon. Here we go. When you do first times first, what do you get? 4. Here's the moment where the square root goes away. What happens when you do outside? Negative 2 root 5. Inside, positive 2 root 5. If I have positive 2 root 5 and negative 2 root 5, so we don't write anything for the OI in FOIL. But last, what do you get? Negative square root of 25, which is just negative 5. Positive times negative is negative. Root 5 times 5 is 25, so it's just negative 5. All right? So the numerator is 2 minus root 5, and the denominator is just negative 1. The bottom is now a rational number instead of irrational. That was the goal. If you can divide both of these terms by this or simplify it at all, go ahead. Can you do 2 divided by negative 1? What is it? Negative 2. Can you do negative root 5 over negative 1? What happens? I just showed you what happens. What happens when you have a negative over a negative? It turns to plus root 5. That would be the final answer for example 6. Negative 2 plus root 5. And I have a little trick to show you here to check your work. If you go to your calculator and you type in the original problem like I did here, 1 divided by 2 plus root 5, you get this weird decimal. Our answer, if you recall, was negative 2 plus root 5. If you type that in, you get the same weird answer, proving that we simplified it correctly. All right? It's a good check at the end before you turn in a test to make sure you did it right.